Hi, I'm Mr. Barr, and let's see, where am I? Am I there? Is this me? Here I am. This video is going to be about how to calculate the distance between points. So here are my 2 points. Here's a coordinate system. I'm going to plot these 2 points, and we're going to do this graphically first, and then I'll give you a formula. But it's better to understand why it's working graphically. So 4, 3, 1, 2, 3, 4, 1, 2, 3. There's my first point. And -4, 1. And what I'm looking for is the distance between those 2 points. What is that distance? Now, this graph paper is, it's a 1/4 inch grid. So what I'm looking for is how many squares, or how many 1/4 inch squares of this length. So this line is actually, I'm going to count it, 1, 2, 3, 4, 5, 6, 7, 8. It looks like it's about 8 and a little bit squares based on a 1/4 inch square. But how can I do this mathematically? I'm going to turn this into a right triangle. There we go. I'm going to count the length, or I'm going to figure out the distance of each leg of this. So this leg is 1, 2, 3, 4, 5, 6, 7, 8 units long. And this one is 2 units long. Right triangle. I have the length of each of those legs. Bring back any wonderful things from other classes. This side right here is called the hypotenuse. A long time ago, there was this guy named Pythagoras. He came up with a theorem, or one of his followers did. I don't know which it is. It's called the Pythagorean theorem, and this is what it looks like. It says that if I square the sum of the square of the sides equals the square of the hypotenuse. What I have is 8 squared plus 2 squared equals this side squared, which we call c. A squared plus b squared equals c squared. Pythagorean theorem, one of the big boys of math. So what's that going to give me? 8 squared is 64 plus 2 squared is 4. That equals c squared. 64 plus 4 is 68 equals c squared. So some number squared is 68. Now that's not a perfect square. I know 7 squared is 49. 8 squared is 64. This is going to be a little bit bigger than an 8. Ooh, isn't that what I thought it was going to be? Like about an 8. Whoa, what just happened there? Okay, I don't think, it really got big on my screen. Maybe it looks normal for you. Wow, that's weird. Everything just got huge. Okay, let's keep going, right? So I'm going to take the square root of this. The square root of 68, well, that would be just c. Can I fix this? Okay, I'm going to keep going. And that would be the square root of 68, 8.25. So the distance between those 2 points is 8.25. Well, is there a way to do this just using those points? Well, think about this. This was at, my first point is at 4. My other x is at -4. If I go x1, here's the formula. I'm going to derive this right now. x1 minus x2. I'm going to square it. I think this is the distance. If x1 is 4 minus x2, which is -4, squared, isn't that an 8? There's my 8. Let's do the same thing with the y's. y1 minus y2 squared. The first y, what was my first y? My first y was 3. My second y was 1. 3 minus 1 squared. Hey, well, here's my 8 squared plus my 4 squared. Excuse me, my 2 squared. Oh, man, my lights just went out. So what I really look at, I have the 64 plus the 4, and then at the very end, I need to take the square root of that. So here's what the official, this is called the distance formula, although you could do it by plotting things out and turning them into I'm Googling something right now. Distance formula. How are they going to write it?
Kind of feel like it doesn't really 1 versus x2 minus x1, aren't they? Yes, they are. Okay, here's the official one that if you Googled it right online, it's this distance formula. Hopefully you can see this. I can't even see myself. Distance formula is this. It's the square root x2 minus x1 squared plus y. Man, this is a crummy video today. y2 minus y1 squared. Find the distance between the x's. Find the distances between the y's. Square them. Take the square root of that. That's the distance formula. It really, I know I put x1 and x2. It doesn't matter. It doesn't matter which point you consider to be your first point and which one you consider to be the second point. Just stay consistent with it. So maybe you want to say, hey, the point on the left is always my first point. The one on the right is always my second point. Just stay consistent with it. Do the math. You've got it. All right. Thanks. I'm going to look at this one after the fact and see what happened. Did my really over here on my screen, my head is enormous right now. All right. That's it. Bye.